Okay, so this is the second lecture of our course. In the first lecture, we did some definitions of data, sample, population, population parameter, sample statistics, and we did some sampling methods. In the second lecture, we are doing the types of data. So there are two types of data, so we are doing those two types of data, and we do frequency table construction. What are frequency table and how we construct those, relative frequency and cumulative frequency. We talk about these frequencies. Okay, so this is something related to our statistics process, collecting data and then organizing the data. So while organizing the data, we may need to construct the table with frequencies. So that's what we are doing in today's lecture. Okay, so there are two types of data: qualitative data and quantitative data. Right? So qualitative data describes the quality or category of an item. So this is also known as a categorical data. Okay, so qualitative data describes the quality of an item, and it is also known as the categorical data. For example, male, female, religious affiliation, these are qualitative data. Quantitative data represents numbers, counts, or measurements, such as the age, a number of siblings, annual income, etc., etc. Right? So these describes the quantity. So these are quantitative data, and these male, female, and these things, they describe the quality of an item. So there are two types of data. The first question is, classify each of the following types of data as either qualitative or quantitative. So we have to figure out that which type of data is these. Okay. So brand names of shoes in a consumer survey. So brand name of shoes is qualitative data because these are the names of shoes. So this is qualitative data. Okay. Height of students is quantitative because we can measure, it has a number. So quantitative data. Audience ratings of a film on a scale of 1 to 5, where 5 means highest. Okay, so this look like numbers. There are numbers, but this is the rating. So 5 means the excellent, 4 means very good, right? 3 is good, 2 is poor, 1 is worse, like that, right? So this represents the quality of the film. So even though it says 1, 2, 3, 4, 5, those numbers, this represents the quality, because 5 doesn't mean just the 5, right? So 5 means it is the excellent movie. So the ratings of film is a qualitative data. Okay, so this is qualitative data. Okay, now the second question is, we circle the correct answer. So let's see what is here. A survey of automobile parked in the student and staff lots at a large college recorded the make and model of the automobiles. The variable make is of which type? Make is categorical data because make is a category. Make is like Honda, right? Honda, Toyota. These do not represent number. These represent the quality or category. So it is categorical. The amount of time spent watching television or playing video games is considered a significant factor on predicting childhood obesity. 290 parents of school-aged children were asked to estimate the number of hours per week that their child spent watching television or playing video games. This is an example of what types of variable? Categorical variable or quantitative variable. Okay, so here the numbers are being involved, right? So 290 parents were asked how many numbers of hours they watch television. So this is number of hours. We ask for the number of hours in this research. I mean, in this process. So how many hours the children watch TV? So that is quantitative. Okay. Now, discrete quantitative variables. Discrete quantitative variable is it always forms the set of separate numbers. Like say a quantitative variable is discrete if its possible values form a set of separate numbers such as 0, 1, 2, 3 and so on. Discrete variables have a finite number of possible values. Number of pets in a household, so we can count those, right? So how many pets? Like 5 pets, there are 6 pets, or 2 pets, or 3. We can count, right? Number of children in a family, we can separate them. Like the first child, the second child, the third child, we can separate them, right? We can count them separately. And the number of foreign languages spoken by an individual, like so we can count, we can ask how many language someone can speak, right? So some can speak 1, some 2, some 3. So we can have those separate numbers, right? So these are discrete quantitative variables. Continuous quantitative variable, let's say the quantitative variable is continuous if its possible values form an interval. Continuous variables have an infinite number of possible values. Okay, so it can have infinite number of possible values. For example, height, weight, age, amount of time to complete an assignment, etc. Let's see. So, so what does this mean? Like, say, if we measure the height of someone, then someone's height maybe can be 5 foot, like 6 inch, a 7 foot 5 inch, 7 foot 5.5 inch, like, you know. So there are infinite values it can have. There is not like someone has 1 foot and then 2 foot or 3 feet or 4 feet or 5 feet. It is not like that. We can have like a 5.5, 5.6, 5.7, 5.8. So there are many possible values for the height, right? So height, weight, like someone can have like you can have 150.72 pounds, 160.42 pounds. So there are infinite values that it can have for these height, weight, and age. Like see, age is like 20 years 5 months, right? So These amount of time is spent to complete assignment, 3 hours, 5 minutes, 3 hours, 6 minutes. So there are many ways, many infinite numbers. So to represent these data, we need to have an interval. Okay, so we cannot include everything in single numbers, and we can't write them separately for each data. So we will categorize like 5 to 6 feet, 6 to 7 feet, 7 to 8 feet, right? So that's how we divide. That's how we make separate groups. So that is called an interval. Okay, so that is called an interval. Interval is like if we are measuring the height. So height is in between 4 to 5 feet, and 5 to 6 feet, 6 to 7 feet. So we put all those height in that category. So that's how we we make an interval. We make intervals to represent these data. So these are called quantitative continuous variables, continuous quantitative variables. Okay, now frequency table. A frequency table looks like this. See, we have the grades, how many students got an A. 3 get A, 5 get B, 9 get C, 4 get D, and 2 get F. Right, so this type of table is frequency table, where it gives the count. Frequency is the count. Okay, so let's see, right? Frequency is count. So how many people or how many students got these grades? So we counting those students, number of students, and those grades. Okay, so that is basic frequency table. It doesn't have other information. It just have the grades and frequency. Frequency is the count, number of count. Okay, so that is called basic frequency table. This table has 2 columns. The first column lists all the categories of the data, and the second column lists the frequency of each category, which is the number of data values in the category. Okay, for example, the final grade of students in class were as follows: C, A, B, C, B, A, F, and then the frequency table is given this side. So see here, A, how many A? See, we can count. This is 1A, 2, 3. Right? So, and there are no other A. So how many A's? So there are 3 A. So that is the frequency table. And that's in the same way you can count how many are B, C, and D, and F. And the relative frequency. Now, what is a relative frequency? Relative frequency represent the percentage. Relative frequency represent the percentage or fraction or decimal, and those are relative frequency. And mostly the relative frequency is represented in percentage format, in percentage form. And this is the formula to get relative frequency. To get the relative frequency of any item, what we do is we divide by the total and multiply by 100. So that's how we get the percentage, right? So to get percentage, so this is divide by total, divide by total, and then multiply by 100%. So that's how we get the relative frequency. Okay, so if you want to find out what is the relative frequency of A, then you divide 3 by the total. So you add all total, and then you divide by that total number, and then multiply by 100. So 3 and 5, 8, and 9, 17, 18, 19, 20, 23. Right, so 3 divided by 23 times 100. So that's how we get the percentage, and that is the relative frequency. And the cumulative frequency of any category is the number of data values in that category and all preceding categories. Okay, so to get the cumulative frequency, we need to add all previous numbers, like for this 3, and for this 3 and 5, 8, and for this you add these. Okay, so 3 and 5 is 8, 8 and 9, 17. So the cumulative frequency is 17. for this cumulative frequency 21, and for this 23. Okay, so we add all preceding frequencies. Okay, so this question, let's do this question and then you'll understand it. So this says that complete the frequency table given above by adding columns for relative frequency and cumulative frequency. So we add columns for relative frequency and cumulative frequency, and we complete the table with that. So let's see here. So we have grades, right? And then frequency. Now let's do relative frequency. And then let's do that cumulative. Frequency. Okay, grade A 3 frequency. Now grade B is 5, grade C is 9, D is 4, and F is 2, right? So these are given in the question. These will be given in the question, right? So we don't need to do anything for this. So now you add these numbers. Okay, so you add, you get 23. Okay, so you get 23 total. And now for the relative frequency, see here the relative frequency is divide by total and multiply by 100, right? So you divide by 23 and multiply by 100. So 3 divide 23 times 100%, and that gives you 13%. Now you do 5 divide 23 times 100%, and that gives you 21.74%. And the same way you do 9 divide 23 times 100%, and this is 39.13. And then 4 divide 23 times 100%, and that is 17.4%. And then 2 divide 23 times 100%, and that is 8.73%. Okay, so I'm doing these calculations by using calculators. I divide by 23 and multiply by 100, so I get this. You do not need to solve these divide and multiply process. You can calculate in calculator and write down just the percentage numbers. Okay, so you don't need to solve these steps, but I show here to give you the idea how we do this. So these are the relative frequency. Now cumulative frequency is, let's say, the first item has the same number as cumulative frequency. Okay, so we get the same number 3 for the first item, and for the second item you add these two. 3 and 5 is 8. Okay, so you keep adding. Now the third is you add all 3. So you add these. So 9 and 5 is 14, 14 and 3, 17, right? So you can write 17. You write 17. 17 is cumulative frequency for that C. Okay, so what we can do is you can either add all 3 numbers here, or you can add 9 to the previous cumulative frequency, like this 8, because this 8 we get this 8 by adding those 2 numbers, right? So you can add 8 and 9 and you get 17. Okay, now what I'm gonna do is now I'm gonna add these number with 4. 17 and 4 is 21, because when I add 17 and 4 mean that we add all these numbers, because we get 17 by adding these 3. Now we are adding 4, right? So we adding all 4 numbers. So you can add 4 and 17 to get 21. Now 2 and 21 is 23. So this is the cumulative frequency for these items. Now here the last number, the last item in the cumulative frequency must be the total number, right? So because we add these numbers, and for the last item we add all numbers, right? So we get 23. So the total number has to match with the last item in cumulative frequency, means the last cumulative frequency. Okay, so this is how we get the frequency. This is just the frequency. And then relative frequency. For the relative frequency, remember that we are dividing by total and multiply by 100. Okay, so we do always we do this, and this is the process to get percentage actually in all math. Okay, so we're doing this way to get the relative and cumulative frequency. Now the next question is, consider the following 20 points data. So the data is given. The question is, make a frequency table including the columns for frequency, relative frequency, and cumulative frequency. Okay, so what you do is, see, these are the data is like 76 and 76, 76, 76. We have some 76, 70, 84. So these are the numbers, right? So we have the score. So these are scores. And then frequency. And then relative frequency. And cumulative frequency. Okay, so we write this way, and then you put the scores. So first the minimum score. So we start with minimum. That is the better way to write. Okay, so the minimum is 72, I guess, right? Yes, 72 score. So how many 72 we have? See, we have 1, 2, 3 and 4. So we have 4 72. So let's first finish the score and frequency part. Okay, so after that we have 75, and there are 1, 2. There are 2 75s, and then we have 76. So we get 4 76. See, 1, 2, 3, 4. There are no other 76, so 4 76. And then 84. The next number is 84. And there are 5 84s. 88. And there are 3 88. And then 94. So how many 94 we have? So 1, 2, 2. 294, right? So these are the frequency. So what is the total? So let's add the total. Total is so 6 and 4, 10, 15, 20. Total is 20. Okay. Now for the relative frequency, you do what? You do divide by the total and then multiply by 100. So you get 20%. 2 divide 20 times 100 is 10%. 4 divide 20 times 100 is 20% again. 5 divide 20 times 100 is 25%. And then 3 divide 20 times 100 is 15%. And the other one is 2 divide 20 times 100, so this is 10%. Okay, so these are the relative frequency. Now cumulative frequency is 4, then 6, then 6 plus 4 is 10, 10 plus 5 is 15, 15 plus 3 is 18, and 18 plus 2 is 20. Okay, so you get this thing. 4 is the first one, and then the second is you add these two, the third you add these three, fourth you add these four, fifth you add all five, and the sixth you add all. So you get that. Okay, so this is how you get the frequency, relative frequency, and cumulative frequency of any data given like this. Okay, so these are the basic frequency table. These are also called the basic frequency table with the relative and cumulative frequency, and these are without class interval. Now sometimes we need class interval. Okay, so for example, if it was like 76, 72, 73, 74, and if there were many numbers in here, we couldn't list all these, and it would be hard to list all the number. So in that case, we sometimes we need the class intervals. Okay, so like this class interval 1 through 5, 1 through 5, 6 through 10, 10 to 11, 11 to 15, 16 to 20, like that. So we put all the numbers which fall in this category in here. So like here we count all those numbers from 1 to 5, and then we write down how many numbers in there in between 1 and 5. Okay, so these numbers, this frequency count how many in between 1 and 5. A table that shows classes or intervals of data with a count of the number of entries in each class is called a frequency table with class interval. So this is one example of frequency table with class intervals. And these are class intervals, like 1 to 5, like see this 6 to 10. This is a class interval, and this is second class interval. This is the first class interval, this is second class interval, this is third class interval. Okay, so this is second class interval, second class interval. Okay, and this is the frequency of second class interval. All right, now these numbers in the class intervals, these numbers like 1, 6, 11, 16, 21, 26, these are called the lower limit of the class interval, and these are called the upper limit of the class interval. So let's see, these numbers are called the lower limit, the lower limit of these class intervals. Okay, these classes. See, the 1 is the lower limit of first class. Okay, so this is the lower limit of first class, and this is the lower limit of the last class, or you can say sixth class. Okay, see 5, let's see 15 is called the upper limit. Upper limit of which class? The third class, right? So third class, upper limit of third class, and so on. So that's how we get the first lower limit and the upper limit of those classes. Okay, now the class width is the difference of two consecutive classes, the lower limit of two consecutive classes, or the upper limit of two consecutive classes. Okay, so when you subtract any two numbers, the first class, the lower limits, right? So you can subtract 6 and 1, you get 5. You can subtract 11 and 6, you get 5. You can subtract 16 and 11, you get 5. 21 minus 16 is 5. 26 minus 21 is 5. So the difference of any two lower limits, right? So you go to subtract, and what you get? 26 minus 21 is 5, right? So this is called the class width. So this number is called the class width. Class width. Okay, so the class width is same. Even if you subtract the first two limits, the lower limits, or you subtract the second and third, you subtract the third and fourth, you take fourth and fifth, it doesn't matter, you get the same number, right? So that number is the difference between the two consecutive lower limits. Or you can subtract the upper limits, 30 minus 25, 25 minus 20. So that difference is called class width. So here for this example, the class width is 5. Okay. Now, so these are the steps in constructing the class intervals. So how do you construct the class interval? So here are the steps. So I'm going to follow these steps to construct the class intervals and represent these data. Okay, so let's see. This question says the following sample lists the price of 30 GPS navigators. Construct a frequency distribution that has 7 classes. Okay, so first step is decide on the number of classes. So we need 7 classes. So this question says we have 7 classes. Write down into the 7 classes. So here the number of classes is 7, and then we need to make a frequency table like this by using 7 classes. It has, see, this example has 6 classes, 1 2 3 4 5 6. Now we need 7 classes for this data. Okay. Now the first step was decide on the number of classes. So we need 7 classes. Find the class width. Now the second step is find the class width, determine the range of the data, and then divide the range by the number of classes, then round up to the next convenient number, right? So what is the range for this data? So here the range is highest minus the lowest number. That is called the range. Highest minus lowest number is, highest number here is 450, minus 59. So 59 is the lowest number and 450 is the highest number. Here is 450, right? So that is equals to 391. So we get the range, determine the range of the data, then divide the range by the number of classes. Now you divide 391 divide by 7. Okay, 391 you divide by 7, you get 55.86. So when you divide the highest minus lowest by the number of classes, you get 55.86. Now you can round up, so you get 56. Okay, round up to next convenient number, 56. And now what you do is, let's see, now you make the table. Okay, so you have the price, and frequency. Okay, so you always start with the lowest number, which is 59. So you start with 59. And then what does this 56 do? So this 56 is, now let's write a note here. Now keep adding 56 to get next lower limit. Okay, now you add 59 and 56. Okay, 59 and 56 is 115. Don't get the upper limit now. You just get the lower limit. So you get the lower limit by adding 56 to each number. Okay, so you add 56. So here you get, what you did here is you add 56. Okay, you add 56 and you get 115. Now you add 56 again. 115 and 56 is 171. The next number is 171. Then you add 56 again. You get 227. Okay, and now you add 56 again. So 283. And then you add 56 again. 339. And keep adding until you get 7 classes. We got what? How many classes? We got 1, 2, 3, 4, 5, 6. Now we need one more, right? So you add 56 again. So you get 395. Okay. Now we decide the upper limit. Now once you do all the lower limits, now you can decide the upper limit. Now if this starts with 115, what has to be here? 114. Because it goes from 59 to 114 and then it starts with 115, right? So it goes 115 to which number? Goes to 170, because here is 171. So it has to go up to 170. Okay. So again, look at the next number and then you decide. So see 171 and 227. So this is starting at 227. So it has to be 226. Okay. So 227 to 283. So 282. This is 283 to 339. So 338. And this is 394. Okay. Now what is here? Because we don't have other number to look at. But you can always add 56, right? So you add 56 to this number so you get 450. Okay, so you can add 56. This is just kind of like formula, adding 56. So how you get that 56? You find out the highest minus lowest number and then divide by the number of classes. And it gives you in the question how many classes. The number of classes will be given in the question. Like it gives 7 classes. So you divide by 7 and then you get the number, and then you add those numbers. And first decide the lower limits and then you decide the upper limits. Okay. So now you got the class intervals. Okay. Now you need the frequency. So what you're doing now is you count in the data, you count how many numbers in between 59 and 114. Okay, so you need to count that number. So when you check that, let's see, 59 to 114, how many numbers in there? So this is 59 to 114. 1, 2, 3, 4, 5. So there are 5 numbers within this range, within 59 and 114. Okay, so starting at 59, ending at 114, there are 5 numbers in between those in the data. So that is 5 frequency. Okay, in the same way you count how many in between 115 and 170. Okay, so 130 is in between these numbers, right? Between 115 and 170. So 1, 2. So that's how you count, and I already counted it, and there are 8 numbers. So 8 frequency, and within this range there are 6 numbers, 227 to 282. There are 5, 283 to 338. There are 2, 339 to 394. There is 1, and 395 to 450. There are 3 numbers. Okay, so this is how you get the frequency and the class intervals. Okay, this question is again the same type. So these are the heights given using 5 classes. Construct a table, construct a frequency distribution table using 5 classes. So the number of classes, 5. We need the range, the highest minus the lowest. Okay, so this is the highest number is 74 minus 67. Lowest is 67, which is 7. Now divide 7 by 5 because the number of classes is 5. So you get 7 divided 5 is 1 point something, 1.4. Okay, see, now this is 1.4. You can round it up to 1.5 because see, we have here the data was big, like it started at 59 and goes up to 450, but here the data starts with 67 and ends at 74. So you can round it up to 1.5. So that is the convenient number, 1.5. Okay, now add 1.5 to the first lower limit to get second lower limit, and so on. Okay, so you add these. Now see, these are the, let's see, the classes, and frequency. Classes, starts with 67. Now add 1.5 to 67 is 68.5. Now add 1.5, 70, 71.5. 1, 2, 3, 4. Now we need one more. 73. Okay. So we added 1.5 to each of these numbers, right? So this goes up to 68.5. So here is should be 68.4. And this is 69.9. 71.4. 72.9. And this is 74.5. So we add 1.5 to get 74.5. Okay, so that's how we get the classes. Now frequency, how many numbers in these classes? 67 to 68.4. Now you count 67 to 68.4. 69. This is 1, 2, 3. Oh, no, not 69. We need 67 to 68.4. So this is not on that. This is not on that. 1, 2, 3, 4, 5, 6. Right? So we get 6. Now 68.5 to 69.9. That will have 69. That will contain 69. So 1, 2, 3, 4, 5. Now 70 to 71.4. So 70, 71. Those are here. 70 and 71. Because it goes up to 71.4. Okay, so there are, you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Right, and then so on. You get 2 in here and 4 in here. Okay, so that's how you get the frequency and classes. Okay, now answer these questions after constructing the frequency table. So we got the frequency table. Now we answer this question. A height of 69 inch belong to the class having what frequency? 69 inch. 69 belongs here, right? So the frequency is 5. So the 69 belongs to the class having what frequency? 5 frequency. What percentage of 30 adult male had height between 73 and 74.4? 73 and 74.4. There are 4 adults, but we need the percentage. So to get the percentage is, what you do? Divide, right? Divide by total and multiply by 100, right? So how many are there? 4. Divide by total. So what are the total? 30 is the total. Total is 30. So 4 divide 30 times 100%. So this is for this question, okay? So 4 divide 30 times 100 is 13.3%. So that is the percentage of 30 adult male that have height between 73 and 74.4. What proportion of 30 adult male has height less than 70 inch? Less than 70, what proportion? Okay, less than 70 is these, right? So these are less than 70, these two, because this is 70 and these are less than 70. So 11 for the third question. 11 out of 30. Okay, so the proportion is just divide by total. For the proportion, you just divide by the total. For percentage, you divide by total and multiply by 100. For proportion, you just divide by total. So 11 divide 30. 11 divide 30 is 0.3666. Okay, here 0.366, which is 0.367. This is the proportion. So for proportion, divide by total, just divide by total. For percentage, divide by total and multiply by 100. Okay, so these are two different questions. So let's okay, so that's how we complete the second lecture. So we did a lot of things here. Please look at all these things. We did mainly the frequency table, relative frequency, cumulative frequency, and then we did how to get these classes and how to construct these frequency tables. So this was in the second lecture. Now in the third lecture, we will do some graph methods of representing data, bar graph and pie chart, and those stuffs we do in the third lecture. Okay, so we'll see you in the third lecture. We stop here. Thank you.